In this video, I'm going to do an example of the angle side case when we were dealing with solving a triangle. So for this example, we're asked to solve a triangle and we're given some information. Angle A is 40 degrees, B is 35, and little a is 60. And then by solving, that means they want to know the rest of the information with that triangle. So they want to know what is angle C, what is little a, and what is little b. So I think what I'll do first is just try and draw a sketch of this triangle to get my mind wrapped around what should be happening. So I think I can draw a 40-degree angle. Looks something like this. That's angle A. And then I have another angle of 35 degrees, so I'll put B down here as well. 35 is just a little bit less. Something like so. And then little a was given to us. That's the side length opposite angle A. And we know that value. That value is 60. So I'm going to come over here and draw side length A and label it 60. What I don't know is little c. I don't know how long this base is, or this side length. I don't know how long little b is, and I don't know at this moment the angle of C. But I'm assuming it looks something like that. I've got two little acute angles, and I know one of the side lengths is 60. Typically when we're solving triangles, the very first thing we do is draw the triangle, try to sketch it out, and then identify the case. In this situation, in this case, we were given an angle, and then we were given next an angle, and lastly, we were given this side. We call this side, angle, angle, or you could call it angle, angle, side. So the case here is angle, angle, side. Notice the S is not between the two angles. I was not given an angle and then the side length between the two angles. I was given an angle, angle, and then a side. This can be written frontwards or backwards, so also SAA. Now for this case, the law of sines is perfect. The law of sines, we like to have a pair of information. So I was given angle A and little a. So this is just begging us to use the law of sines. So I'm going to set up the law of sines. And I'm going to use the A's, and then I have a B. So I'm going to use sine of angle A over little a, and that will be equal to sine of angle B over little b. So I just used the first two ratios here. Sine of A over A equals sine of B over B. I don't need the C part yet. And now I have an equation with only one unknown. I knew three pieces of information, so now I have an equation with one unknown. I should be able to solve for it. Right now, the unknown is in the denominator. I'm going to take care of that. I'm going to multiply both sides by b to move it to the left-hand side of the equation. The b, I want it to be by itself. So right now it's being multiplied by sine 40 over 60. So in order to take care of that, I need to divide both sides by sine 40 and multiply both sides by 60. Maybe I'll do one step at a time. So I want this 60 to go to the other side of the equation. I can multiply both sides by 60 just like I did the b. Now b is being multiplied by that value sine of 40. I want b to be isolated, so I'm going to divide both sides by sine 40. All right. Now, I could do some estimations, but I don't have these values memorized. They're not they're not pretty. I know sine of 30 and sine of 45, but these values are not on the unit circle. So I'm gonna just go to a calculator to get some, just a decimal approximation. But this is the exact value of side length B. 60 sine 35 over sine 40. To finish out this problem, I'm going to just throw that into a calculator. I am in degree mode. So I have 60 times sine of 35. I'm going to then divide that by sine of 40. And I get it about 53 point, oh, I don't know. I'll just do one decimal. 53.5-ish degrees. All right, so now some organization may come into play. I'm gonna create just a table of information. I was given angle A as 40 degrees. I was given angle B as 35 degrees. I was given A is 60 units. And I just found, oh, I said degrees, that's not degrees. And I just found little b measures 53.5 units. Yeah, little b is a side length. So I was not talking about degrees, I was talking about some unit of measure. Why not? All right. Now to find angle C or little c, I'll have to know at least one of them. For the law of sines to work, I need to set up maybe this proportion, the two ratios that equal to each other. But in order to find one of these, I need to know the other one. Well, I happen to know that the three angles of a triangle will add up to 180. So I can find angle C right off the bat. Angle C is equal to 180 minus the other two angles in the triangle, because the three triangles add up to 180. They're supplementary. So I think that's 105 degrees. 180 minus 75 gives me 105. All I'm lacking is the length of side length C. I can use the law of sines again to find it, now that I know angle C. So for sure I'm going to use sine of angle C over C. And I'm going to set that equal to either the B's or the A's. The B's would be okay, it would work. But B does use an estimation, so maybe I should go back to A where I know those exact values. Either will work. We're just going to get an approximation here anyway. But I'm going to go back to sine of A over A. Similar to before, I'm going to multiply both sides by 60C and divide by sine 40. So I did multiple steps there, but I multiplied both sides by C, so it's on the other side of the equation. And then C was being multiplied by sine 40, so I divided by it. And C was being divided by 60, so I multiplied by it. So I'm going to throw this into a calculator just to get a decimal approximation. I know the glare is not good here. But I'm going to do 60 times sine of 105 degrees. And then I'm going to divide by sine of 40 degrees. And I'm solving for c, so not a degree. This is just some unit of measuring. I'm getting 90 point, I'll round that up to 2, so 90.2-ish. This would be an exact value. Over here, this is just an estimation to help us visualize it. So something to notice about these triangles, the bigger the angle, the bigger the side length. Keep passing that up. The smaller the angle, the smaller the side length, the medium angle. All right, so that's an example of the angle side case. We were given a pair of information, so we went straight into the law of sines. And then we could find that third angle because the angles of the triangle are supplementary, and then we set up another relationship to find that last c. All right, let me do another example, very similar. This time the angle side angle situation, or that case. It's very similar. We were asked to solve a triangle, and this time we're given this information. So I've been given 3 pieces of information, and they want to know the rest of the triangle. So first step is to maybe draw a picture and identify the case. I'm telling you the case, but maybe you don't know it. So, well, 2 angles. These look very similar to the previous one. I think I can draw a 45-degree angle. So I'm putting B in this position, 45 degrees. And then C, I'll put over here as 30. Should be a little bit smaller than 45. And this time, I know the side length between those two. Angle A would be up here somewhere. So I do know this side length measures 80 units. So I was given an angle. I was given a side length, and then I was given another angle. We call this the angle side angle case. And if I wrote it left to right or right to left, I'm going to get this ASA, angle side angle. Now this also uses the law of sines, but we'll notice right off the bat that I'm not given a pair of information. I don't know my A's or my B's or my C's. And in order to use the law of sines, I really do need a pair of information. But I know that the angles add up to 180. So if I were to draw this triangle out, this angle up here, angle A, has to sum with 45 and 30 to give me 180. So that's 75. Angle A is going to be 105 degrees. The angles of a triangle must add up to 180. They're supplementary. So now I can use that pair of information. Sine of angle A over A will equal to, and I could do either one, sine of B over B. Let's just do that. Pair of information, I now have 3 pieces of the triangle, so I can solve for that 4th one. To solve for B, I'm going to do this whole multiplication rigmarole. I'm going to put the B on the other side, and then kind of flip this and move it over. I claim B is equal to 80 sine 45 over sine 105. That's the exact value. Ooh, that looks very familiar, sine of 45. So I'm about to just shove this into a calculator because sine of 105 is not so pretty. But I happen to know sine of 45 is root 2 over 2. So for fun, I'm just going to play around and simplify a little bit. 80 halved is 40. You could probably use a sum and difference ID to probably get the exact value of sine 105 and continue to reduce. But for the purpose of this video, I just want an estimation of that side length B. So I'm just going to bust out the calculator. I'm going to type in 40 times the square root of 2. And then I'm going to divide by sine of 105 degrees. My calculator is in degree mode. And I get about 58.6-ish. And that's little b, that's not degrees, that's a side length. So little b, I can go off to my triangle and say, hey, that's going to measure 58.6-ish. Getting kind of messy, but I only need one more piece of information, and that is little c. So I'm just going to repeat this process. I'm going to use the law of sines again to relate A's to C's. Sine of angle A over A equals sine of angle C over C. Same thing. C will equal 80 sine 30 over sine 105. Oh, that 30 is pretty. I know sine of 30, but I'm just going to throw this into a calculator. I get about 41.4-ish. We're solving for little c, that is a side length of the triangle. This is not degrees. That is 41.4 units. Now that I know all three side lengths and all three angles, we've solved the triangle. So that's an example of the angle side angle case. We just used the law of sines. I hope that helps.